The second thing I want to show you has to do with the fact that the electric field inside a uniformly charged sphere is 0. Here I have a sphere which is not entirely closed. I can't make it closed because I want to demonstrate to you that there is no electric field inside when I charge it uniformly. And since I have to get inside, I need an opening. There's nothing I can do about it. Since there is an opening, the electric field is not exactly 0 inside. It's only true if this is a complete closed surface and if the charge is uniformly distributed. But it's a good approximation. The opening is quite small. And what I'm going to do is I'm going to charge this sphere. I'm putting charge outside. I use a device that we have not used before, but that's not so important. But here is now that hollow sphere. I'm going to put charge on there. Let's suppose it is positive charge. So this will be positively charged. Since it is a conductor, as we will learn, I think the next lecture, or at least this week, that the charge will automatically distribute uniformly. It only does that on a conductor. And now, to demonstrate to you that there is an electric field here, I will use induction. I have 2 ping pong balls painted with conducting paint. They touch each other. Under influence of this electric field, this one will become negative and this one will become positive. We've discussed that last time. You create a dipole. It's not important that it is a dipole. I separate the two. I have negative charge here and positive charge there. I will touch any one of these 2 balls, it doesn't matter which one, with the electroscope, and you will see that there is charge there. So I have demonstrated then that there is an electric field outside that sphere. Now I will do exactly the same demonstration, but now I put these 2 conducting balls inside. So here they are. I touch them. You just have to trust me that I really will touch them. And then I will take them out. And if I didn't make a mistake, if I didn't touch the rim by accident, then I will show you that there is no electric field inside. It means there is no induction. So these balls did not pick up charge. I show you with the electroscope that indeed there is no charge on it. So that is the way I want to do this. So there's the electroscope. Here's the sphere. And the way I'm going to charge it has a nice name. It's called electrophorus. Hard to pronounce. I first rub a glass plate with cat fur. Then I take a metal plate, I put on top, and I touch it with my finger. And now I transfer charge. And you think about it, why that is. I put it on here again, touch it again with my finger. I'm again charging it. Put it on top, touch it again with my finger. I want a little bit more charge, so I'm rubbing this again. Put this on top, touch it with my finger. Every time I do that, I feel a little shock. Put it on there. Touch it with my finger. Okay, let's hope that's enough. So now comes demonstration number 1. These 2 spheres, conducting, completely discharged, I bring them close to this sphere. There they are. I separate them. So now they must have picked up charge. Shall I use this one or this one to touch the electroscope? The same to me. My right hand or my left hand? Who wants right? Who wants left? The right ones have it. And there's the charge. So I've shown you that there is an electric field there. Through induction, I've created charge on here. Now I'll do the same inside. It's always tricky, because if I hit the rim, then it's not 0. This one has to go in first because the opening is too small. Then the second one has to come in. Now I have to touch them. And I really do. I wouldn't cheat on you. Not this time. They are now in contact with each other. And now I take one out. And I take the other out. Which one shall I touch it? There shouldn't be any charge on either one of them. We had left before or we had right before? Well, let's do this one. This one? Who is for left? Who is for right? The lefts have it. Oh! What happened? I must have touched the side. There's no way around it. I'll make sure that there's enough charge on it. I'll charge it once more. Discharge them. Okay, we'll do it again. Go inside. Go inside. I touch them. Take it out. Take it out. Nothing. Nothing. Maybe a teeny little bit. Well, the electric field inside is not necessarily exactly zero, but it's extremely close. The last thing I want to show you has to do with the fringe field